Okay, guys, I had to try to convince myself to make this tonight. I just know the first day back from spring break will be a lot easier if I have this made already. So I'm going to jump right in here with quadratic functions, and we're going to talk about graphing and finding zeros. Graphing and finding zeros. Here you are, here's parabola kitten. Parabola, what's a parabola? Well, let's find out. Okay, a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a is not equal to 0. That forces the function to have an x squared term. This is called standard form of a quadratic function. Here you see 3 basic examples. The graph of a quadratic function is called a parabola, and accenting the second syllable on the word, parabola. Not parabola, it's not a disease. The axis of symmetry of the parabola is the vertical line through the center of that parabola. So in this case over here of our lovely parabola here to the right, our axis of symmetry is actually also the y-axis. And I'm kind of giving you this kind of dotted line thing here. So it's a vertical line. That means it has an equation. In this case, x equals 0, because that's what's always true on that line. The x is always 0. No matter what the y is, x is 0 there. The highest or lowest point of the parabola is called the vertex. So the vertex would be like this point right here, which in this case is the origin, but that's your vertex. In this case, again, 0, 0. But that's the turning point, you could say, of the parabola, or it's the highest or lowest point. Well, what makes it a highest point or a lowest point? Or a maximum or minimum. So maximum would be a highest point, minimum, again, lowest point. Well, if you've got a quadratic function where the a value right here, ax squared, the coefficient of x squared, if you've got a quadratic where that's positive, your parabola opens upward. In other words, it's a smiley parabola. Happy parabola. All right, and that means the vertex of that parabola is a minimum, a lowest point. All right. Or if you have an a that is negative, so again, the coefficient of x squared, if it's negative, that means your parabola opens downward, and it's a frowny parabola. So again, kind of sad. And there's its vertex. That means its vertex is a maximum point. Maximum. So minimum, lowest point, maximum, highest point, and it's all about what we call the leading coefficient. Let's write that one down. That's a good one to know. The leading coefficient. Let me pick a better color. A is sometimes called the leading coefficient. So if it's positive, you get a happy parabola, opens up, minimum value for the vertex. If it's if the leading coefficient is negative, you get a sad parabola, opens downward, has a maximum point for the vertex. Now we can find the axis of symmetry in the vertex of a parabola quite easily. There's a little formula, and the formula starts out with x equals negative b over 2a. Negative b over 2a. So that's our formula right here. Okay, so the opposite sign of b divided by 2a, simplify, and you get the equation for the axis of symmetry. Because remember, the axis of symmetry is a vertical line, and that's an x equals equation. Once you have that, you plug the x value into the function to get the y value of that vertex. So let's do this example right here. Let's find the axis of symmetry and the vertex of this parabola. Let's start off by identifying what a, b, and c are for this particular quadratic function. A, the leading coefficient, is 1. B, the coefficient of the linear term, or just the x term, that's 4. And C, that's negative 12. Now, I don't need C if you look up there in the formula, but it's a good thing to be able to identify it. So I want the opposite of B, so the opposite of 4 is negative 4, divided by, and this is an x equals here, 2 times A, which is a positive 1. So negative 4 divided by 2 is negative 2. And that gives me my axis of symmetry. Okay, now that I have found my axis of symmetry, hold on just 1 second. I'm actually out of space, so I'm going to move that up there. Okay, now that I found my axis of symmetry, which is x equals, whoops, get my writing tool back. Let me move that back up. Get my writing tool back. X equals negative 2. Now I'm actually going to plug it in. And I'm going to plug it in, of course, for x, being careful to note that I have to make sure I put the number that I'm plugging in for x in parentheses. Now this should look kind of familiar. This is actually how I encourage you to write out and then type in your calculator when you have to do a problem like this. So I wonder why she did that. Now we know. Now we know. It was just good math. It was just good quality math. All right, so y equals -2, the quantity squared is +4, plus -8 for 4 times -2, and then -12. So 4 plus -8 is -4, minus 12 is -16. So the vertex of our parabola is -2, -16. And so we can find that without having to use a calculator. So that's a good thing, because if you plugged this in a calculator right here, you wouldn't be able to see this vertex on the regular screen. You wouldn't be able to see it, and you would be confused as to how exactly you're supposed to find it. Because even if you know the secret little fun tricks of the calculator, you still have to be able to see it on the screen for those tricks to work. I know, it sucks, but that's a good thing. We don't want the calculator getting too smart. Okay, guys, we're going to do just a little bit of graphing here. So first, let's start by making sure that we have a lovely coordinate plane ready to go. I'm going to put a y-axis down the center. It's not going to be perfect because it's very hard to draw perfectly here. And an x-axis, not in the center, but a little bit lower than that. And put my little arrows in there. All right, so we're going to graph these 4 quadratic functions, and I'm going to show you a little bit of graphing by transformation, which is where we know how changing an original, and then we got the first one is called the parent function, y equals x squared. We can look at how you can change that to create the other graph. All right, so we start off by thinking you plug in 0 for x, you get a 0 for y. So the vertex of this one is 0, 0. And then you plug in a 1 for x, you get a 1 for y, because 1 squared is 1. And the same is true of -1. That -1, the quantity squared, is a +1. Plug in a 2, you're going to get out a 4, which puts you right here. Okay, same thing on the opposite side, and that's partly that axis of symmetry we learned about. We know what symmetry is. We learned that in science. We learned that in art. So we do know what symmetry is. We can use symmetry here to graph. And you plug in a 3, you're going to get a 9, and that's going to put us right up here, which is the last point I'm going to be able to graph on either side. And okay, and there's our parabola, y equals x squared. So this next one, y equals x squared minus 4, well, that's going to be what's called a vertical vertical shift, or a vertical transformation here. That's it's going to go down 4. So every one of the points we just graphed, the y value is -4 from where it is here on the red one. So for this blue one, plug in a 0, you get a -4. And you can, again, follow the same pattern. From there, you can go right one, up one, and that left one, up one, and that's going to be a pair of points. You can go right 2, up 4, because of that 2 squared, right? 2, 4. And again, you can go 3, let me do it with the pointer. 3, 9. Right 2, there. Okay? And the same point on the other side. So that one is 4 points lower. And you know, this is something that your graphing calculator and the table function on your graphing calculator is super useful for. All right, let's look at the next one. The next one is y equals 2x squared. So this one is what we call a vertical stretch. It's twice as tall. So you still have 0, 0, because when you plug in a 0 for x, you get a 0 for y. Instead of the relationship where you go right one, up one, it's right 1, up 2, because the y value is twice the height. Instead of right 2, up 4, it's going to be right 2 and up 8, all the way to here, because again, the y value is twice as high. So that's what we call a vertical stretch. So it's kind of like somebody took the top and the bottom of it and pulled to stretch it out, like Stretch Armstrong. It was a toy from the 70s. I never actually had one. My husband had one. We found that it melted in a box in his parents' attic because it got really hot up there. Anyway, that's just a really bizarre aside. Sorry. Anyway, last one. Last one has a negative sign out front. So when you have 0, 0, that's still, again, going to be the vertex. But when you plug in a 1, you get a negative 1, because 1 squared is 1, but then you tack the negative on after the exponent, as we learned before. And so you get the same thing on the other side. And then instead of 2, 4, it's going to be 2, negative 4. So these are some cool things, and I encourage you to take your TI-84 calculator in class, TI-84 plus, and experiment with graphing some similar parabolas. You can make some cool looking graphs, but you're also understanding something about the graphing as you go along, and kind of play with that table format or function as well. Okay, let's talk about zeros. I think it's this and one more slide. Yep, this and one more slide. So the zeros of a function are the x-intercepts of the function. The zeros of a function are the x-intercepts of the function. So to find zeros, you have to do one of two things. You either have to graph a function and identify its x-intercepts, or you have to substitute y equals 0 and solve the resulting equation. So let's try a couple. 3 to be exact. So the first one says y equals negative 2x plus 8. Well, actually, this is going to be much easier to do if I just plug in a 0 for the y and solve. So I'm going to do this. I'm going to add 2x to both sides on this one and get 2x equals 8. And that means that x must equal 4. So the 0 for that first one is 4. All right, on this one I can plug in 0 for y again, but I have to understand something before I continue. Oh, I'll add 4 to each side. 4 equals x squared. Well, I can say I can take the square root of x squared. Now, we haven't talked about this yet, but I can take the square root of x squared, and I can take the square root of 4 over here. And there's actually two answers to that. There's positive 2 and negative 2. So I might need that visual. I might need that graph for the second one. And for this one, I just plain don't know how to deal with this. And it was funny, a couple students might remember, you tried to solve this in class and you got really confused because we haven't learned how to do it yet. So I'm not going to be able to do that. So let's do a graph for the second one and the third one. Heck, let's do a graph for all three. So, oh, hey, that's terrible. Let's try fixing that because that was terribly messy. All right. So let's try just doing a graph for all three, just so we understand what we're looking at here, okay? All right. And I put that axis up nice and high because that's where I'm looking. That's what I'm looking for. I'm looking for where it crosses, each one crosses that x-axis. So let's do the first one in orange. Okay, so that's a line. It has a y-intercept of 8, so I'm not going to be able to use the y-intercept, but I can use the x-intercept I found, which is an x-intercept of 4, and a slope of negative 2. So down 2, right 1. All right, so there's that line. And yes, indeed, that's where the x-intercept is. Is it 4? Well, I know I used my x-intercept to graph it, but that was the most convenient way to graph it right there. Okay, let's do this dark green for this one. We just did this one, actually. It's got a y-intercept at negative 4, and then remember we would have our pattern of right 1 up 1, right 2 up 4. Up, there's one of the zeros, so it's the number 2. Left 1 up 1, left 2 up 4. So there's our parabola, and we can see our zeros, which I showed you already. I know I went through it a little fast, a tad fast. But just think, if you take the square root of 4, you actually don't know if it was positive or negative 2 that you were squaring to get the number 4. All right, the last one of these. And I'm just going to use purple because it's my favorite. Okay, so we want the y-intercept of negative 12. And I think that's negative 12. Let's double count that in. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know that is a y-intercept of 12, negative 12. I'm not going to be able to graph its vertex because I didn't make enough space for that. But I'll just have to maybe provide some other ordered pairs for it. So let me pause it so I'm not spending a ton of time wasting, adding minutes to your video. So hold on, let me do this graphing. In class, you would probably be doing this with a graphing calculator right now anyway, because we haven't really talked about how to do it without. I talked about that, finding that vertex and axis of symmetry, and that's all great, but if you can't fit it on your graph, it's kind of useless, or at least a little bit less useful. All right, hold on. Let me do this graph for you. So a table of values is actually a mental table of values, and some patterns that I recognize and that I will share with you in class are how I actually graphed that. But the point here is that if I can find a way to graph it, and sometimes if that's just the graphing calculator, that's actually okay. If I can find a way to graph it, I can find the zeros of the function. And in this case, it was -6 and +2. Now, I really want you to think carefully about this particular function right here, this expression on this side. I want you to think about what you would do to factor that. And I want you to note the fact that these were -6 and +2. I want you to see how those two numbers relate to this particular expression. Maybe you can even factor it. Maybe. And I want you to look for a pattern there. And we will talk about that pattern in class. And hopefully this video hasn't gotten too long. And you guys had a good spring break, but I hope you're ready to get back to the grind. See you in class.